Okay, so now that we know the chain rule, we're going to apply how that chain rule works with the product rule and the quotient rule. So if it says differentiate g of t is equal to t minus 2 over 2t plus 1 to the power of 9. Now remember, we're going to treat it just like we did with the chain rule in the last case. We're going to say that g of t is going to equal the outer 9 and t minus 2 over 2t plus 1 to the power of 8, and the inner, where we're going to take the derivative of that t minus 2 over 2t plus 1. Remembering that we have our high and our low from that quotient law. So what I have is I still have the 9 and t minus 2 over 2t plus 1 to the power of 8. And then if you can remember from our quotient law, it was the low d high less high d low, draw a line, and square below. So we're going to take our low, which is that 2t plus 1. We're going to take the derivative of the high, or the derivative of t minus 2, which is just going to give us 1. We're going to subtract from that the high, that t minus 2, divided by the derivative of low, multiplied by the derivative of low, which is going to give you 2. And that's all divided by the low squared, that 2t plus 1 squared. Now, we know based on our exponent laws that this exponent of 8 is going to be applied to the numerator and applied to the denominator here. We also know that we're going to expand out this numerator so we can combine like terms. So what is that going to give us? That's going to give us 9, and we have t minus 2 to the power of 8. On the bottom, we have 2t plus 1 to the power of 8. Well, on the bottom, we still have 2t plus 1 squared. And up in the numerator, when I take the 2t plus 1 minus t minus 2 times 2, then that's going to give me 2t plus 1 minus 2t and plus 4. Well, a positive and negative 2t are going to cancel each other out. And all I'm left with is that 1 and 4 are going to give me a 5. Which means that g prime of t is going to equal, well, the 9 times 5 is going to give me 45, t minus 2 to the power of 8s, and in the bottom, those are the same base, which means I have 2t plus 1 to the power of 10. and that is fully simplified. Let's try this with the product law instead of the quotient law. So we have two things we're multiplying together. We have factor 1, and we have factor 2. So we know that y prime is going to equal factor 1, 2x plus 1 to the power of 5 times derivative 2, or d over dx of that, x cubed minus x plus 1 to the power of 4. And I'm going to add to that factor 2, x cubed minus 1, x plus 1 to the power of 4 times the derivative of factor 1. So we have 1 times d2 plus 2 times d1, just like with our product rules. Then I'm going to say that factor 1 is still factor 1, 2x plus 1 to the power of 5. The derivative of 2 is where we're going to use that chain rule. So that's where I'm going to wind up with that 4 times the inside to the power of 3 multiplied by the derivative of the inside, 3x squared minus 1. Remembering once again, there's my outer and there's my inner. Same thing for the next part. I have the x cubed minus x plus 1 to the power of 4. And I'm going to multiply that by, for the outer, it's going to become 5 and 2x plus 1 to the power of 4. And the inner is just going to become 2. Which means what I actually have is 4, 3x squared minus 1, 2x plus 1 to the power of 5, and x cubed minus x plus 1 to the power of 3, plus 10, 2x plus 1 to the power of 4, and x cubed minus x plus 1 to the power of 4. Well, I have two terms here. So I'm looking for common factors. So from the 4 and the 10, I have a common factor of 2. I have 5 2x plus 1s. I have 4 2x plus 1s. So they'll have at least 4 2x plus 1s. And I have 3 x cubed minus x plus 1s and 4 x cubed minus x plus 1s, which means that they both have at least 3 x cubed minus x plus 1s. And this is my GCF. what is remaining is 2, 3x squared minus 1, 2x plus 1, plus 5, x cubed minus x plus 1. And what I have left that is not part of my greatest common factor, I'm going to expand and combine like terms. So we're going to keep going. I have 2 and 2x plus 1 to the 4, and x cubed minus x plus 1 to the 3. And then I have 2, and I'm going to have 6x cubed plus 3x squareds minus 2x's minus 1 plus 5x cubed minus 5x plus 5. Or 2x plus 1 to the power of 4's, x cubed minus x plus 1 to the power of 3's, and 12x cubed, 6x squared, minus 4x, minus 2, plus 5x cubed, minus 5x, plus 5, which means that y prime is going to equal 2, 2x plus 1 to the power of 4, x cubed minus x plus 1 to the power of 3, and 17x cubed, 6x squared minus 9x and plus 3. And there's my answer.